بسم الله الرحمن الرحيم. In this lecture, we are going to speak about the simplex method. Last time I spoke about the linear programming techniques to find the optimal solution for linear programming or linear optimization problem. In this part, we are going to speak about the simplex method, which is another technique to find the optimal solution for linear programming problem. Starting with the definition that a linear programming problem is said to be a standard maximization problem in standard form if its mathematical model is in the following form. We have objective function b equal to c1 x1 plus c2 x2 plus up to c sub n x sub n. This will be our objective function, and the constant range will be linear inequalities, and all of them should be or must be less than to some number, where all the variables x1, x2, xn are greater than or equal to 0. So we have linear programming problem, which is the objective problem. We need to find the maximum value, b equal to some linear function or combination, and we have linear inequalities less than some constants. This will be our problem. And we need to find the maximum value using this technique, which is called the simplex method. And to find the solution using the simplex method, we are going to write the problem in a form called the normal form. And to apply this method, we are going to take one or two examples. Let's try to find the maximum value or maximize. We need this maximize the problem z equal to 3x1 plus 2x2 subject to the constant range 3x1 plus 4x2 less than or equal to 60. And 4x1 plus 3x2 less than 60, and 10x1 plus 2x2 less than 120. Now I need to maximize this or find the maximum value for the objective function, which is this one. This is the objective function. And I need to find the maximum value. To do this one, we are going to write the problem in a normal form. This form of the problem is not in the normal form. So step number one, we are going to write it in a normal form. Normal form means write all of these in term or in form of the equations. For the objective function, we will have z minus 3x1 minus 2x2 equal to 0. So leave the right-hand side equal to 0, move everything from x1 and x2 to the right, left-hand side, keeping only the constant. If we have any constant, we'll keep it to the right. But in this case, we have no constant, so we make it equal to 0. For the first inequality, we have a 3x1 plus 4x2. I have inequality. I need to make it equation. To do this one, we are going to add one variable. We call it slack variable. This we call it a slack. This is slack variable for the first inequality. Same thing for the second one. We have 4x1 plus 3x2 equal to 60. Again, we need to add another slack variable for the second inequality, which is S2. I call it S2. For the third inequality, we have 10x1 plus 2x2 equal to 120. Again, we need to add slack variable that is S sub 3. Now I'm going to write this form in matrix form or simplex table or tabular, the simplex. So we have the z variable there. We have z. We have x1, x2, s1, s2, s3, and b, the right-hand side. For z, the coefficient is equal to 1 in the first equation. X1 is minus 3. Now we are writing the coefficients. Minus 2. S1, we don't have, so it is 0, 0, 0, and 0. For the second equation, there is no z, so we'll have 0. Then we have a 3, 4, 1, 0, 0, and 60. Third equation, we have z. There is no z, so it is 0. Then it is 4x1, 3x2, and 0s1, 1s2, 0, and 60 again. Last one, we have 0z, 10x1, 2x2, 0s1, 0s2, and 1s3, and the right-hand side equal to 20. So this is the objective function there, and this is b. Sometimes the objective function can be written at the end, will be the last row. This will not make a big difference. So we can keep it in this form. Now I need to find the maximum value using the simplex method. So we are looking for the negative numbers in the first row. Negative numbers. And we need to make them equal to 0. I have in the first row or in the objective function. If we write it down, it will be in the last row. So we are looking for the negative numbers in the objective function. In my form, it is the first row. I have minus 3 and minus 2. I can take any one of them. Some textbook will say that take the most negative number. Either you can take the most negative number or you can take any one of them will be okay. But choosing the most negative number will be faster to get the maximum value. Now, we need to find the quotient. I'm going to divide b by these numbers. So the first one, I have 60 divided by 3. These are the quotient. 60 divided by 3 equal to 20. Second one, 60 divided by 4 by this number equal to 15. Last one, 100 or 120 divided by 10 equal to 12. Now for the quotient, we are using the minimum non-negative quotient, the minimum non-negative. And the minimum one is equal to 12, which means I'm going to choose 10 to be my pivot. It means that I'm going to make all the elements above this number 10 equal to 0. Using the row operation to make them equal to 0. So for the first one, 10 R1 plus 3 R4. I'm going to multiply the first row by 10 and the last row by 3 to make this equal to 0. I need to make this equal to 0. So I will have the first row will give me 10 minus 30 minus 20, 0, 0, 0, and 0. Third row, I will have 0, 30, 20, I'm sorry, this is 6. Then we have 0, 0, 3, 360. Add them. I will have 10, 0, minus 14, 0, 0, 3, and 360. Now this will be my first row. Now R1. Next one, I need to make the second element in this column equal to 0. So it will be 10 R2 minus 3 R4. Multiply the second row by 10, I will have 0, 30, 40, 10, 0, 0, and 600. Multiply the fourth row by minus 3, I will have 0, minus 30, minus 6, 0, 0, minus 3, and minus 360. Now add, I will have 0, 0, 36, 10, 0, minus 3, and 240. This is R2. Now for the third row, which is 4, I need to make it equal to 0. I multiply the third row by 10. It is 10 R3 minus 4 R4. And this will give me, just I need to separate these. Multiplied by 10, I will have 0, 40, 30, 0, 10, 0, and 600. By minus 4, the fourth row, it is 0, minus 40, minus 8, 0, 0, minus 4, and minus 480. Add, I will have 0, 0, 30, 2, 0, 10, minus 4, and 120. This will be now R3. So the numerics now will give me, first row is 10, 0, minus 14, 0, 0, 3, and 360. 60. Second row, it is 0, 0, 36, 10, 0, minus 3, and 240. Third one, 0, 0, 32, 0, 10, minus 4, and 120. And the last one, the bypass that we use, it is 0, 10, 2, 0, 10, 2, 0, 0, 1, 0, 0, 1, and 120. Again, this is my objective function. Now we can see in this step now, we have some columns have only one non-zero entry. You can see this one has only one non-zero. This one only one non-zero. This one also one non-zero entry. We call these basic variables. I have x1, this is x1, x2, s1, and s3. This is b. The other we call non-basic. The other variables. These are x2 and s3. When we say they are non-basic variable, mean they can, or we can set them to be 0 in this step. But x1, s1, s3, we can find some values for them. Now, in this step, we are not done, because in the simplex method, we shouldn't have any negative in the first row. In the first step, we had two negative numbers, minus 3 and minus 2. Now I have only one negative number, that is minus 4. I have to get rid of this negative number also, minus 14. Sorry, minus 14 is negative number, and we have to remove this negative from the first row. Again, I need to find the quotient. Divide b by these numbers. So the first one, which is 3, or 240, divided by 36. 240 divided by 36, it is about 8. Less than 8, it is about 7. Or not 7, yeah, between 7 and 6. It is about 6 point something. Second one, 120 divided by 32, about 3, almost 4. It is less than 4. And the last one, 120 divided by 2, equal to 60. So we are choosing the minimum one. The minimum one is this one. So it means 32 will be my pivot here, 32. So 32 will be my pivot number. Which is equal, in this case, I need to make minus 14 equal to 0, 36 equal to 0, and 2 equal to 0. So for the first row, to make it equal to 0, I will have 32 R1 plus 14 R3. This will give me 320. And 32 times minus 14, or that will be, keep it now. Okay, it's 0. This is 32 and minus 14. I'm going to write it in this form. And 0, 0, 96, and 11,520. This is 32 times 360. And 14 times the second one, which is 0, 0. This will be 14, or 32 multiplied by 14. Then I have 140, 0, and minus 42. And 6, or 1,618. Add them together. I will have 320, 0, 0, 140, 0, and minus 42, and 50. It will be 54. And last one will be 13,200. Now this is R1. Now for the second one, which is 36. The second element will be this 36. So multiply the second row by 32. R2 minus 36 R3. Doing the same thing, we will have, this will give me the result for this one is 0, 0, 0, 320 minus 360, 48, and 3,000, or yeah, 3,360. For the last one, number 2, just multiply by minus 16 will give me R4. I will have 4 is equal to the, doing the operation, it will be 0 minus 16 or minus 160, say, because this will be R3 minus 16 R4. This will be minus 160, 0, 0, 10, and minus 20, and minus 1,800. So the matrix will be 320, 0, 0, 140, 40, and 13,200. Second row is 0, 0, 0, 320, 0. Another 0, 0. One 40, 40. This will be 0 minus 96 and 7, 680. And third one is 0, 0, 32, 0, 10, minus 4. This is not changed because this is my pivot there. And last one is 0 minus 160, 0, 0, and we have 10 minus 20. Minus 1,800. And we can check that. We can see in the first objective function, there is no negative. Since there is no negative, we can stop at this point. Now I need to find the values for Z, the maximum value, and also the values for x1 and x2. From the first row, I will have this system. I have a 320. This is Z, x1, x2, s1, s2, and s3. And this is B. From the first equation, I have 320 Z plus 140 S2 plus 40 S3. But S3 and S2, you can see this one. These are non-basic. It means that we can say S2 equal to S3 equal to 0. Since we have more than one non-negative or non-zero element in these columns, we can set S2 and S3 to be equal to 0. And this is equal to the right-hand side, which is 13. But since these are equal to 0, I can cancel this. These are zeros. So Z equal to 13,200 divided by 320, which is equal to 41.25. So this will be my maximum value. To find x1 and x2, from the second column, we have minus 60 or minus 160, x1 plus 10, s2 minus 20, s3 equal to minus 1,800. But again, these are zeros. So x1 in this case equal to 180 or 1,800 divided by 160. And that will be about 11.25. This is x1. From the third row or third column, we have 32, x3, I'm sorry, x2. We are using this one. S2 equal to 0, S3 equal to 0, so we'll have 120 divided by 32, which is equal to about 3.75. So the solution for this optimal solution or the problem, maximum value Z equal to 41.25. And this will be in the location where x1 equal to 11.25 and x2 is equal to 3.75. So this is the solution for this optimization problem using the simplex method. The idea is to remove any negative from the objective function row or from the first row, or in some other textbook they are using the last row. So this is the idea, to remove any negative number from the objective function row. And if we got all of them positive or zeros, then we can stop and find the values for x1, x2, and the maximum value. So this is the idea of the simplex method.